Solving equations in one variable. So when you're solving equations, it's very procedural. A lot of times a teacher might give you like a sort of acronym in terms of which steps you do in what order, but I'm not going to really go into that. Basically, you kind of work out to in. You try to work away from the variable and then come to it. So let's just jump in here. It says, here we go, solve the following equations for x. So letter A has 4x minus 7 equals 25. So we're trying to isolate x, get x by itself. So I see there's a minus 7. So what I'm going to do is I'm going to add 7 to cancel that out, to get rid of that. So if I add 7 on the left side of the equals, I need to add 7 on the right side as well, just to maintain that equality. So now I'm going to have 4x equals 32 because 25 plus 7 is 32. And again, I'm solving for x, so I'm trying to get x by itself. And now I have a 4 that's being multiplied to the x. So in order to get rid of a 4 that's being multiplied to x, the opposite operation or the inverse operation would be to divide by 4. That's going to cancel that out, and then it'll just be a 1x, like we want, just an x. So, of course, if I divide by 4 on the left side, I must divide by 4 on the right. So now I have 8. So x is isolated. I have x equals 8, and that's my solution. And of course, if we want to check our answer, we can always plug it back into the original equation, which is 4x minus 7 equals 25. So if I do 4 times 8, that's 32. Minus 7 does equal 25. Okay. Let me show you. I'm going to kind of do I think I'm going to do the left column with all these problems. Let me show you C. So C has an extra step. There's something to distribute. So we've already kind of done distributing. So we're going to multiply that 2 to everything in the parentheses. So 2 times 1x would just be 2x. 2 times negative 3 would be negative 6. That's what we have so far. Next, we want to combine like terms. So whenever you can combine like terms, and remember you can only combine on the same side of the equals. So I have a negative 6 and a 4. Maybe I'll highlight those. These can combine to negative 2. Negative 6 plus 4 is negative 2. So I can combine it because they're on the same side of the equals. I know some teachers like to draw like a little line down there to organize your work, and I'll just leave that line there, and you can do that too. All right, so now we're back at a two-step equation just like we had on letter A. So I see a 2x minus 2, so I want to get rid of that minus 2. The inverse of subtracting 2 would be to add 2. That's going to get rid of that. Of course, I'll do that here as well. So that's 12, and then I just have 2x left over. And last step, again, we're isolating x. So 2 is being multiplied to x, so the opposite of multiplication, division. That'll just get us a 1x. Of course, have to do it on the other side. X equals 6. E is unique because we have x's on both sides. So now we have x's in kind of multiple places on both sides. So what we need to do is get x over to one side. Okay, so maybe I'll draw this vertical line again. So I need to get x over to one side. I can't solve for x's on both sides. And I can't combine them either. I can't just do the 9x plus 7x and get 16x because they're on different sides of the equal. Which side do I even put it on anyways? Like, I don't know. Would it go on the left side or the right side? We can't do that. So what we're going to do is we got to eliminate x from one of the sides. So I'm just going to take away this 7x, get rid of that over here. And then, of course, I have to do it to the left side as well. And notice I put it underneath the 9x because that's its like term. So now I'm going to have a 2x plus 10 equals 6. And there we go. So now we're set. We got a two-step equation. So all we had to do on this one is kind of get this one moving, is get x over to one side, get rid of it on one of the sides. Okay, so now we can solve it. I'm going to subtract 10. So now I have 2x equals, that would be negative 4. Divide by 2. And now I have x equals negative 2 as my final answer. G is very similar. we just kind of have like an extra step. So we have x's on both sides still. We have x's on both sides. But before we want to move any x, we have something we can combine. Look, we have a 2x and a 5x. Those can combine. So let's sharpen it up now. That would be a 7x minus 3 equals 3x plus 5. And now let's get into our solving steps. So we have x's on both sides. Same thing. I want to get rid of one because I can't solve from here. I'm going to minus this 3x, subtract that, and I'll do it over here because, you know, you got to do it to both sides. So that's going to be 4x minus 3 equals 5. And then we're back at a two-step. Add 3. 8, 4x comes down, divide by 4. X equals 2. Okay. I is a little bit different. Now, what you notice with i's is, again, we're trying to solve for x, get x by itself. That entire left side, that 6x plus 3 part, is being divided by 7. It's being divided. The entire left side is being divided by 7. So in order to get rid of that division by 7, what we're going to do is we're going to multiply by 7. So that's going to cancel that out. And of course, I'd have to multiply this entire side by 7. So this side is negative 21. And then this side, we just have our 6x plus 3. So that's the idea. You know, the inverse operation of division is multiplication. So if I'm dividing by 7, I have to multiply by 7 to get rid of that. And then we're at a two-step equation. So here we go. Minus 3, minus 3. I have 6x equals negative 24 now. Divide by 6. X equals negative 4. Quite similar on K. Actually, let me do L. Actually, I'm going to do L instead. I'll let you do K. Okay. So this one, it's very similar. Just now we have this kind of plus 1 stranded. So I'm going to just subtract that 1. Let's get rid of that first because that 1's not being divided by the 5. So we're not going to deal with that quite yet. Let's just get rid of that 1 first. 11 minus 1 is 10. And now we can start doing the exactly what we did in the last problem. So the entire left side is divided by 5. So now is a good time to multiply that side by 5. So I'm going to multiply this by 5. That's going to cancel that out. And then, of course, I'd have to multiply this by 5. So I have an 8 minus 4x equals 50. So now I have my two-step again. So I have a positive 8. So what I'm going to do is I'm going to take away that 8 by subtracting 8. So now I have a negative 4x equals 42. Divide by negative 4. To isolate the x, divide by negative 4. And I get, what's that? Is that negative 10.5? It's got to be, right? Negative 10.5. I'll just go to a decimal there, but you can leave it as a fraction if you like. Simplest form. Okay. Just double check and make sure my steps are good. I think they're good. Okay. All right, M. I think this is the last one I want to show you in here, just because it kind of takes a lot of what we've done so far and it's kind of putting it all together. So here we go. First step, there's actually a couple things I can do right now. So what I'm going to do, I'm going to distribute. And I'm also on this side, it looks like I combine these like terms. So I'm going to do that. So let me first distribute. That's going to be 4x plus 32. Still have that minus 5 there. And then negative 3x plus 10x is 7x. And then even here, if I'm not, so I got x's on both sides, so that's an issue. But I see I can combine some more stuff. Like for instance, I can combine the 32 and the -5. So why don't I do that? So 32 minus 5, that'd be 27. Okay, so I have 7x equals 4x plus 27. So I've distributed, I've combined all my like terms. And now I'm trying to isolate x. So I got to get x over to one side. Now, it would make most sense to take away this 4x. So I'm going to subtract 4x. Because if I took away the 7x, there'd be nothing over there, and you just have a 0, and that would look kind of funky. So I'm going to take that out of here. So that's 3x equals 27. And then we're almost at it. Just divide by 3. So we have x equals 9. Okay, I'll let you work with the rest.